Welcome. We are in the chapter on logic, and today we look at 1b, quantifiers and counterexamples. Statements with quantifiers. Here are two nice examples of statements that have quantifiers. Now, remember, a statement is a claim that is either true or false. But take a look at these two statements. The first one says, some mice don't like cheese. And the second one says, every old person is wise. So the some and the every give us a sense of quantity. That's why these are called quantifiers. Some mice don't like cheese. Every old person is wise. But these two statements are also a little bit different. Now, the first one is an example of an existential quantifier. Isn't that a great word, existential? Tell your friends today you studied existential quantifiers. They'll be impressed. When you see words like some, there exists, at least one, that tells you the existence of something. Like in this first example, some mice don't like cheese. That means there exists a mouse that doesn't like cheese. Or you could say, at least one mouse doesn't like cheese. So the existence. Some other examples, at least one country exports uranium. There exists an even prime number. So these are statements with existential quantifiers. Now, the other example, every, that's an example of a universal quantifier. When you see words like all, every, or the opposites, no or none, those are universal quantifiers. There are absolutes, like all dogs are mammals. No U.S. state contains a desert. So absolute terms, all or none. One of the hard parts of working with quantifiers is negating them. Now, in arguments, we often need to do this. If someone makes a statement with a quantifier, like A, at least one country exports uranium, and if you don't think that's true, what will you say? What is the negation of that? Or if your friend says, for B, there exists an even prime number, and if you don't think that's true, what is your counter-argument? How do you express the negation of that? So, in fact, think about these four statements, the first two with existential quantifiers, the second two with universal quantifiers, and take a second, actually pause and try. Pause the video, see if you can negate these things, and then start the video again when you want to check your work. All right, give it a try right now. All right, we're back. Let's take a look at how we do this. At least one country exports uranium. If that's not true, then no country exports uranium. I'll write that down. And this is kind of interesting. Look how we started with an existential quantifier, at least one country exports uranium, and the negation of that was a statement with a universal quantifier. No country exports uranium. How about the next one? There exists an even prime number. Okay, well, if that's not true, then no even prime number exists, right? Maybe you could say no number is even and prime. Our third example. All dogs are mammals. If you think maybe that's not true, maybe a counterexample exists, well, maybe there is some very strange dog out there that is not a mammal. Some dog is not a mammal. And look what happened here. I started off with a statement that had a universal quantifier, all dogs, and I ended up with a statement that had an existential quantifier, some dog is not a mammal. So it's interesting how negating a statement with an existential quantifier gives us something that's universal, and negating something with a universal quantifier gives us something that's existential. Here's our last example. No U.S. state contains a desert, so the negation of that is some U.S. state contains a desert. Or how about, just to mix up the language a little bit, at least one U.S. state contains a desert. All right, hopefully that works for you. Let's talk about counterexamples. A statement with a universal quantifier is false if a counterexample exists. So think about that last statement. No U.S. state contains a desert. So that's universal. That's an absolute statement. But if I can find one U.S. state that does contain a desert, then that U.S. state is my counterexample. And the existence of a counterexample means that my absolute statement had to be false. Here are a couple examples. Find a counterexample. A, for all numbers x, the absolute value of x is greater than 0. And statement B, if numbers a and b are both multiples of 5, then a plus b is a multiple of 10. These statements are both made with universal quantifiers. The second one is a little bit different. The language doesn't explicitly say all or every, but it's kind of like the idea that every pair of numbers a and b that are multiples of 5 have this property. So can you find counterexamples? In fact, let me put the little icon on there. Pause and try. Pause the video, take a few seconds, see if you can find a counterexample, and then start the video again when you're ready to check your work. All right, let's see what we have here. For A, we might start with some confirming examples. So absolute value always turns things into positive, right? So if I start with a positive 5, I get a positive 5. And if I throw in a negative 3 into the absolute value, I get positive 3. So it looks like from a couple confirming examples that maybe this statement is true. But then, perhaps you think to yourself, what about 0 itself? The absolute value of 0 equals 0, and 0 is not greater than 0. So we have our counterexample. 0 is a counterexample for that claim. So I know claim A is false. How about B? If numbers a and b are both multiples of 5, then a plus b is a multiple of 10. We might just try a couple examples. I don't know, like 15 is a multiple of 5, and 35 is a multiple of 5. And when I add them together, I get 50. Oh, and 50 is a multiple of 10. How about 5 itself is a multiple of 5. That's just 5 times 1. And 25 is a multiple of 5. And I add them together, I get 30. So maybe these are some confirming examples. They're starting to lead us down the path of maybe thinking, oh, this could be a true statement. But then you might think about this. What about 15, a multiple of 5, plus 10? 10 is also a multiple of 5. But when I add together 15 plus 10, I get 25, and that is not a multiple of 10. So the hypothesis is satisfied, both A and B, so individually, the two numbers are multiples of 5, but the conclusion is not satisfied. That sum is not a multiple of 10. Okay, so what is my counterexample in this case? My counterexample is actually a pair of numbers, 15, comma, 10. So that pair of numbers gives me the counterexample I seek. All right, and that concludes 1B, quantifiers and counterexamples.